Hello, everyone. Good morning, good afternoon, and good evening, wherever you are in the world, to everyone who is tuning in. I hope you're all doing all right and looking forward to a nice Christmas. My name is Reem Henry. I'm the SPE-YP chairperson for this season and a Halliburton wireline and perforation engineer. On behalf of SPE Egypt section, I'm very pleased to welcome you all to our session today, the overview of digital transformation in our industry, the E&P industry, which will be presented by a very distinguished speaker. So I advise you all to take full advantage, take notes. We're very lucky to have his participation. Give full attention to the informative session today in order to widen your knowledge and be able to address digital initiatives and digital trends in the industry. Before we start, I'd like to remind you all to please drop your questions in the Q&A section below, and please keep this chat box as much professional and ethical as you can. I'd also like to introduce my colleague moderator, Ahmed Haytham. Shout out. So without any further delay, we would like to welcome Engineer Hemant, who has a Bachelor in Mechanical Engineering from Indian Institute of Technology, Roorkee, and an MBA from Indian Institute Management in Kozhikode. He is currently the Regional Technical Sales Manager for Halliburton Landmark, responsible for business development, client engagement, and solution delivery in the Middle East and North Africa. He has over 20 years of experience in the industry, including a stint with the National Oil Company as an offshore production engineer. Throughout his consulting and business development career, he has helped E&P firms across the world to define and implement their digital initiatives. He commonly speaks and writes about digital trends in the oil and gas industry. So let's welcome Engineer Hemant, and please, the rest stay on mute. Thank you.
Thank you, Reem. Can you all hear me well?
Yes, it's clear.
Okay, so allow me to share my screen. All right, can you all see my screen?
Yes, it's clear, Engineer Hemant.
And let me know when you want me to start.
Okay, you can start as you're already, please.
Sure. Okay. Thank you, Reem, and thank you everyone who is on the call for giving me your time and listening to what I'm going to present. So the topic today that I'm going to present is about digital transformation in oil and gas industry. And the future is here and now, and that is something we should embrace. The topic, the agenda that I'll be covering, I will first talk about the disruptive forces facing the oil and gas sector. What are the key imperatives for O&G industry and how we can overcome and the challenges that the industry is facing from those disruptive forces, and what is the role of digital in enabling the transformation that O&G industry needs to go through. And then if there are any questions, I will be happy to take them at the end of the session. All right, let me start with a few words about the disruption that industry is facing today. So what you see on the screen is nothing surprising. The oil and gas industry, we have been, I think there are some people joining, and I'm just looking for the way to, yes. Yes, so oil and gas industry, we are familiar with the price collapses, and every 5 or 7 years we see those collapses, and when that happens, we see disruptions to the industry in terms of disruptions to the jobs or the investment patterns or the ability of the oil and gas companies to compete. And we also see oil and gas companies going out of the business, and there is some kind of restructuring that happens. And And if you look at the latest commodity crash, we were barely coming out of a 2014 price collapse, and then COVID struck us, and now we saw the prices tumbling, and they reached into the negative territory in April, when the prices were around minus $15 or $20 per barrel, and many analysts, they call it Black April. Luckily, the prices have gone up again, and let me just close it. And it's because of the checks and balances that we have in the market. Now, to an outsider who does not know enough about oil and gas industry, when these price collapses happen, they always act as if it is the first time it is happening. I've been in the industry for about 2 decades, so I've seen the price fluctuations and how they impact the industry. But to the outsider, when they see these events, they ask me the questions: is it the end of oil and gas industry, and how are you going to survive in the low price scenarios, or would the prices go back to $100 per barrel or beyond? And these are the questions that weigh on the mind of common people. But also here, I also sense some anxiety among the young generation that is looking forward to join the industry. So let's try to look at the bigger picture of the price volatility, right? If you look at the oil and gas business and the oil prices over the last 6 or 7 decades, you will see that oil and gas industry is used to the lower price range, and this graph is a bit complicated, but let me explain this to you. So the black line, it is the actual price of oil at the time of the day, and the red line that you see is the price translated in terms of today's dollar value. So if in 1950, if the oil and gas oil prices were around $6 per barrel, in today's money term, it would be around 22, 25, or 30. So if you look at the average oil prices in the last 6, 7 decades, you will see that it has been around $45 per barrel range, and just in the recent times, the average price has climbed to $57, $65 per barrel. Is because of the oil price rally in the last few years. But the point is that as an industry, we are quite resilient to these price shocks, and we actually we have mastered the art of being competitive in the lower price ranges in between the $45 to $60 per barrel. The two spikes that you see when the prices were around $120, $140 per barrel, I look at them as more of anomalies in the bigger scheme of things. So I would say the disruption is nothing new to the industry, and that is something we are used to. But the question is the latest disruption we are talking about after pandemic, is it new? Is there something different about it? And should we be concerned? And the answer to both the questions, I would say, is yes. So let's look at some of the trends beyond simply price fluctuations. So now, so far the oil and gas industry has seen the price collapses, shocks from purely supply and demand, fluctuations, which used to be temporary. But now we are facing a challenge from the emerging sources of energy, and we call them renewable. And these sources of energy are becoming more popular because the technology that is used to deliver those sources of energy is getting cheaper and more easily accessible. So if you look at the prices of solar energy or the wind energy, there has been a dramatic reduction in their prices. And on top of that, there's also the battery technology that is getting better and also getting cheaper. And that addresses some of the gaps in the some of the reach of the renewable and the solar energy. And And also, if you look at the percentage of the wind and solar energy in the overall energy mix, you'll see that it's steadily climbing. So no matter whichever study you look at, you will see that there is an expectation that wind and solar would play a more dominant role in many business sectors, whether it is power or the industrial sectors. And this is a forecast that has been prepared by one investor company, but if you look at other forecasts, they show you the similar picture. Also look at the growth of electrical cars. So, we have seen an explosive growth in the number of cars which are there on the road that are running on the battery technologies. Still, if you look at the total percentage of the electric car, it's around 3%. But if you look at the growth, it has been phenomenal. And although I believe that we would not see such an explosive growth in the recent time because the base grows wider, still there are various forecasts that say that the number of electric cars as a percentage of the total vehicles in 2040 would be around 30 to 50%. So that means the share of transportation sector in the oil demand would go down. And if you look at how the investors are looking at these developments, this year Tesla is a company that makes electric vehicles. Their stock was at an all-time high. This is during the time when other automobile stocks, they were languishing, they were flat. Tesla, it just rose from some $150 to 643 as of 23rd December. So it talks about, it basically highlights the investor sentiments. It's not these trends, but also the investors and the governments and academia. There is a sense that oil and gas may not be a dominant fuel in the future energy mix. And then we also saw this year some of the headlines from the leading governmental agencies or the leaders or investors or even academia who have announced the shift from the fossil fuel to clean energy sources, and also their intention to kind of put less weightage on the fossil fuels in their future strategy and move or prioritize the green energy sources. So if you look at, for example, take EU Commission, right? That's an agency. They have planned to slash carbon emissions by 2030. Then Joe Biden, who was recently elected as U.S. president, he has announced an initiative to cut down increase the investment in the clean energy spending. And then there are investors like BlackRock, which is one of the largest investment firms in the world. They are moving away from the fossil fuels in their portfolio. So these are some of the real trends, real events, which are telling us that we cannot just. Of course, there is also the activism from the common citizens who are demanding for cleaner energy and steps to provide more sustainable sources of energy to the world. But it doesn't mean that oil and gas industry is not going to be around or it's going to die, as many experts they are predicting. And if you look at the forecast, gas demand is still going to be steady. And no matter whichever reports you're reading, they all point to a steady increase in the gas demand, because gas is considered to be a cleaner source of energy. Similarly, if you look at the LNG demand, we saw a record year in 2019 when the demand for LNG was at an all-time high, and as per the wider estimates, that LNG demand is going to be double by 2040. And that demand is going to mainly come from Asia Pacific. So China, for example, is going to consume a lot more gas as the other Asian countries like India and so on. When you talk about oil, although oil consumption will go down for sure, but doesn't mean that the E&P companies will stop producing oil. There would still be need for oil. You will need oil to run petrochemical plants. Also, there would be cars that would be running on the petrol or diesel, and then you'll have the planes running on the jet fuel. So, although the oil demand would come down, the oil and gas companies, they have already announced their plans to increase their oil production by 2030. And these are some of the numbers that have been provided in the report by Rystad Energy. So although there is a certain amount of I would say anxiety today in those who are working in the industry, some of these trends that tell us that the hydrocarbon industry would still be a key pillar of the future energy mix. But at the same time, we cannot assume that's going to be business as usual, right? I think these are some of the changes which are structural, they are fundamental. They will not go away in the next 5 to 6 years. And the oil and gas companies, they just simply cannot continue to operate the way they did in the past. So there are some of the changes that oil and gas companies are making in the way they operate. So we see there's a clear shift away from financially risky or environmentally sensitive exploration and mega capital projects. So as used to be the case many years ago, that E&P companies would invest in the large capital projects, and that would take years to develop. And before they were producing oil, and the E&P companies were getting positive cash flow, and that would take them around 10 to 15 years. But it's no longer the case. The long exploration and capital project lead time, 10 to 15 years, it's, many oil and gas companies, they don't see that as aligned to their business model. They don't want to lock in their capital in the environment where the future oil demand is not very certain, and there's a lot of pressure coming from the investors. Similarly, many banks and the investor, they're shying away from giving money to the large capital projects. And it's also because of the history of how these projects have performed. Many of these projects have faced a massive cost overrun. They're exceeding their budget by 40 to 60%. That is also making investors quite wary of investing in those. And there's also environmental pressure. If you look at some of the environmentally sensitive areas, many O&G companies, they are writing down or selling their assets. Take oil sands, for example, in Canada. In the recent past, companies like Total, Shell, or ConocoPhillips, or Equinor, they have pulled out of oil sands, or they have sold their assets, or they have written down their complete investment. And even the banks, many banks, they are refusing to lend money to the companies who are operating in environmentally sensitive areas. And of course, there is always, increasing the cost of finding and developing fresh basins where geology is not well known, or there's no ready infrastructure to bring oil and gas to the market. So these are the factors which is causing the companies to move away from those money guzzling and time consuming capital projects to a more efficient, operationally optimized and environmentally sustainable value chain, which means they are looking at reducing their exploration risks and cycle time. They're looking at improving their capital project efficiency. They are looking at optimizing field development, reduce the number of wells, and minimize the capital, and also maximizing the uptime and capacity utilization to improve the cash flow, and also maximize recovery so that they can replace their reserves through the existing fields, not really having to rely on the new exploration activities. And doing all of that while being sensitive to the environment. So Now, the mantra in the oil and gas industry, it used to be do more with less capital and resources, but now it is becoming doing more with less capital, resources, and CO2 emission. So all that calls for the transformation, because the many oil and gas companies, their business model, their capabilities, the technologies that they're using, they're not aligned to this shift in the focus to the to this energy transition. So oil and gas companies now, they are trying to transform, and the focus of the transformation is around 4 areas. There is data focus, where oil and gas companies are looking at making better use of the data to take better decisions in terms of where to drill the wells, or how many wells to drill, or whether a prospect is attractive or not. There is a process focus, where the oil and gas companies are looking at doing things in a much better way, using less resources and less time. Then there's a skill focus, where the need is for having the workforce that is equipped with the right skills to be effective at their job. And then there's ecosystem focus, where oil and gas companies are looking at solving the challenges by tapping into their partner ecosystem. So this is how the oil and gas companies are looking to transform themselves. Now, coming to the main topic of this, so I would also pivot, and I would talk a bit about how digital is enabling oil and gas companies to achieve their transformation goals. So you may all be familiar with these digital technologies. I guess they have been talked about so much that I think all of you would have come across them in the various journals or the conferences. These technologies are not new. They have been around for quite some time, but we have seen a steady increase in the usage of these technologies. And I'm going to talk about how they're being used. So we are looking at things like cloud, or Internet of Things, or digital twin, or big data, blockchain, and so on. So if you look at how digital is being applied by oil and gas companies to achieve their transformation goals, talking about data focus, where oil and gas companies are leveraging technologies like AI or machine learning or digital twin to drive the better decisions across the value chain. So if you look at exploration, appraisal, development, the digital is helping companies to improve their subsurface characterization, or improving well placement, or enhancing the designs of enhanced oil recovery, or the wells, or the completion. And similarly, in the production and reservoir management, the digital is helping oil and gas companies to improve their production forecasting, or reduce their maintenance cost, or manage their reservoir better. Similarly, when you talk about process focus, where the goal is to do things faster, taking less resources and less time, their oil and gas companies are driving more automation in their business processes. So again, in the exploration, appraisal, development, value chain, part of the value chain, digital is helping oil and gas companies to automate drilling operations, or reduce the cycle time for well planning, or exploration, or field development. While in the production reservoir management part, oil and gas companies are looking at remotely managing their operations, or integrating the workflows, automating them, enhancing the productivity of the workers who go out in the field to do various kind of activities. Similarly, when we talk about skill focus, digital is again helping their oil and gas companies are looking at ways to accelerate the way they bring the new talent on board and provide them the training. They're also using machine learning technologies to capture the knowledge of subject matter experts, who are not many, and many of them are leaving the industry, and democratize that knowledge to the entire organization. And similarly, when you talk about ecosystem focus, oil and gas companies are looking at collaborating with their partners using open cloud platform. Now, what I'll do now going forward in this presentation, I will drill down into some of these enablers, technology enablers, and how they are providing value to the oil and gas companies. So let's start with data focus and look at the context of why digital is important in delivering a better quality of decisions to the E&P value chain. So all of us are familiar with the data challenges that industry has been facing for, I think, ever since we started drilling our first well. And today, thanks to the technology, we are acquiring lots and lots of data, but the data is not sitting in one place. There, we have got lots of data and different types of data sitting in different data sources. And some of those data sources are in proprietary technology, which makes it very difficult to access the data. So today there's a lot of inefficiencies in the way the end users access the data. They manually download the data, or there's a lot of point-to-point interfaces between different data sources. And that makes it very hard to extract any meaningful insights from the data or understand the pattern across different data types, which could drive the quality of the decisions. So digital is being looked into to liberate data from those silos by providing end users open access to it, then also applying analytics in such a way that it delivers the insights to the decision makers, and by leveraging the integration technologies that could connect the different data sources across the silos. So if you look at some of the common initiatives, and you can see that some of those initiatives, they are already ongoing in the industry. So oil and gas companies, they are adopting technology such as digital twin or AI and ML or data integration to improve the performance in the different parts of the value chain. So some of the initiatives, the initiatives that you see there, they are aligned to the specific challenges which are faced in the different parts of the value chain. So when you talk about subsurface interpretation, the oil and gas companies are looking at better subsurface characterization by applying machine learning technologies to data sets. Similarly, when you talk about field development, the focus there is to reduce the drilling failures by predicting the anomalies in the well, and also improve the design of things like well completions or enhanced oil recovery and so on. And the production and reservoir management part, the companies are looking at predicting the failure so that they can reduce their maintenance cost and they can increase the uptime, or having the better production forecasting so that they can optimize their field development cost, or better workover candidate selection so that they can reduce their well intervention costs and so on. So if I were to take a few examples of these initiatives, one of them is very common today in the industry, which is the fault interpretation. So this is an example from a Latin American national oil company. The fault interpretation is very fault interpretation is quite key in the subsurface characterization. It can help oil and gas companies to identify the drilling hazards or the recovery patterns, and also avoid any safety issues. So this company, they applied machine learning on their subsurface data sets such as well logs and the seismic data, and that allowed them to identify their faults much more clearly than they could achieve with the traditional physics-based tools. That has allowed them to not only optimize their field development cost, because now they can identify where they want to place the wells, but it will also enable them to reduce the safety risks or things like drilling failures. This is another example from another Latin American, Asian national oil company, and this is more focused on the drilling operations. In this case, this oil and gas company, they had lots and lots of data they had collected from their drilling operations, but most of the data was sitting in the unstructured format. So here we are talking about PDF files or the Word document. Now, all of that is very useful data, but it's very difficult to extract and analyze that data using the common analytics tools. So to overcome that challenge, the oil and gas company, they used machine learning technology to extract their NPT or non-productive time contributors from these reports. Now, as we all know that machine learning technologies, they are becoming better and better at reading the documents which are written in natural language. And this initiative has helped this specific company to identify the non-productive time or non-productive causes that were not known before. So as a result of this initiative, they were able to identify the total non-productive time, about 19%, which had caused them a total loss of $200 million in the operations. And that insight would allow them to choose better drilling designs and also benchmark their contractors so to understand the best practices and also apply those best practices to the upcoming well operations. This is an example of another project from a large NOC. In this case, the focus is more on the production operations, where they wanted to predict the failures of the downhole ESP pumps. So electrical submersible pumps, they are used in many places downhole, and they pump out oil in the fields where the reservoir pressure has declined. In many cases, when they fail, they require the costly workover operations to pull out the tubings and repair the ESPs or even replace them. And given the sheer amount of the electrical submersible pumps this company was operating, they wanted to have a better way of monitoring their ESP wells and also reduce the intervention cost. So they applied machine learning technology to analyze their data sets. So we're talking about the real-time data, the maintenance data, their historical well events, work orders, and so on. And the idea of this initiative was to see if they could extract patterns from the data that would allow them to forecast the anomalies in the ESPs in advance so that they could be better prepared, or they could take early action to fix some of those issues. So again, this was a successful initiative where they were able to predict the ESP failure well in advance from 9 to 40 days. And it's still an ongoing engagement. That was a pilot result, but if when fully deployed, it would allow this company to be more proactive in managing their ESPs. Okay, the next is this example is from ADNOC, where they are using what we call as a digital twin. It's the integrated model of their entire producing assets. So as part of that, they have integrated all their reservoirs and oil wells and pipelines and flow networks into a common model, which is what they call as integrated capacity model. And this model, it simulates the flow of hydrocarbons from reservoir into the wells to all the way to the processing facilities, and it allows them a line of sight into the production capacity, so they know what is the potential of the wells at any point in time, and what are the constraints or bottlenecks, and they are using that insight to drive their optimization activities or production forecasting or coming up with the better business plans. And in the word of their executive, today they're using this model to determine which wells to open up when the demand for oil goes up or when to close down when the demand drops, as it happened in this year when the pandemic struck. Again, you can get some more details on this SD paper. I'll share these slides with you. Okay, so we talked about data focus. Let's look at the process focus. So I think this drawing that you see here looks messy, but this is how exactly the business processes in the oil and gas companies look like today. When we talk to many oil and gas companies, they complain that their workforce spend a lot of time in doing the wasteful activities, things like manually collecting the data or cleaning the data or moving it around the different tools, systems, and workflows, or relying on the emails or the telephones to share the information with their colleagues. And as this pandemic showed, there was another inefficiency that was realized by oil and gas companies. That is, their traditional like infrastructure created a lot of issues in the way their workforce was accessing the applications from their home. And also, in many places, we have seen that end users, they're not very happy with the IT infrastructure because it's old and it takes too much time to run the applications and so on. So oil and gas companies now, they're looking at eliminating the waste from their process. So anything that does not add value to the business, they are getting rid of it by standardizing the process, making it lean, and also automating it. So there, the technologies that are being utilized are Internet of Things, cloud, business process management, or virtual or augmented reality. So these are some of the common initiatives that we see in the industry related to the process standardization and automation. Again, the flavor of these initiatives would vary across the value chain. So if you talk about subsurface interpretation, their focus is automating the knowledge work, because more companies are drilling the wells and we do not have enough experts to do the log interpretation or seismic interpretations. So many companies, they are relying on machine learning or business process management to automate some of that expert work so that the experts can achieve a lot more with their limited time. If you look at field development, oil and gas companies are looking at reducing the time it takes to drill the wells or plan the wells. And also they are looking at cloud-based solution to run their reservoir models or subsurface models. Given the fact that cloud provides unlimited capacity for computing and it's easily accessible, many companies are realizing the benefit in terms of the better efficiencies. And when you talk about production and reservoir management, oil and gas companies are looking at more remote operations, real-time operations. Instead of sending their workforce to the field, they are looking at instrumenting the wells, putting the sensors, and monitoring their fields from a single location. And they're also automating the workflows, because in the production and reservoir management, there's a lot of systems involved. So they are integrating those systems and automating the workflows. Similarly, they are equipping the people in the field with the mobile solutions. So now the handheld devices are coming into the operations. We are looking at smart glasses that many field workers are using to easily access the knowledge. So if we look at some of those initiatives in more detail, the Petronas, they recently they decided to move all their G&G applications and seismic data to cloud. And that would allow them to address the inefficiencies that the end users are facing in their workflows. So before they were, everyone had their seismic interpretation applications running on their desktop, and they were accessing their IT infrastructure from their home on a limited bandwidth. It was very slow and inefficient. Now with the movement to cloud, anybody can access the applications through a portal, because all the data processing, computational processes, they're running on cloud. And as you can see, the amount of data and the projects, they'll be moving to cloud, and that will unlock huge amount of huge amount of efficiencies, and helping also end users to collaborate with each other more effectively, because now everybody can look at the same data set and they're running the same models and so on. This is another example from a large Asian NOC where they're using the business process management technologies to reduce the time it takes them to plan their wells. So before, they were relying on a lot of manual workflows, like using spreadsheets or the fragmented software to design the well program, and it would take them weeks and months to design and plan those wells. And also it restricted the adoption of the policies and standards, best practices from well to well, because those policy standards, they were not easy to integrate or access. So in this solution, they are adopting what we call as a digital well program that will automate all the repetitive and manual activities, such as accessing the data from the applications, running engineering calculations. And this would allow one platform for the entire drilling department to perform the well design collaboratively. The result of this initiative would be that the company would be able to reduce their well planning time from months to hours. That's a dramatic reduction in the cycle time. And of course, that will also accelerate their time to oil, because they would be able to drill the wells faster or finish the wells faster. Plus, it will also eliminate the wasteful activities such as data duplication or rework that results from miscommunication across the different departments. Okay, now coming to skill focus. So a skill is becoming a very hot topic in the industry, and there are a couple of reasons for that. There's a view that most of the layoffs that have happened in the industry, even if the oil prices go back to where they were, most of the workforce is not going to join the industry again. And second is many companies are looking at doing a lot more things with the lesser workforce. And third is there's a lot of experienced workforce that has been retiring over the last few years, and that exodus of the experienced workforce would continue as many experienced professionals are reaching their retirement age. The challenge for the company is twofold. One is how they can quickly bring their younger workforce up to speed and make them capable to start being productive as quickly as possible. The second challenge the E&P companies are facing, given the influx of new digital technologies and more digital adoption, they are no longer finding that the traditional skill sets are enough. So in addition to the domain knowledge, they are also looking for the skills around digital technologies. So there was a survey done by Ernst & Young this year, where they asked the oil and gas executives how they look at this skill as key to their success in the next 3 years. And as you can see, that there is a vehement agreement in favor of giving the right focus to the skill aspect. And they also felt that today there is a big gap in some of the digital technologies that are seen as key to their transformations. In this graph, as you can see, that the yellow bars, they represent the deficiencies in the skill availability today in the organization. And the gray bar, they basically talk about the access to the skills in the next 3 years. So there is a clear a need for action, and oil and gas companies, they are looking at investing more in the training program. They're actually transforming their workspace. So I don't know if you've been to the offices of ADNOC or BP or ExxonMobil, they look as cool as the offices in Google or companies like Facebook. So that's one aspect, but they're also looking at the ways to attract the younger generation and bring them up to speed quickly. So that's where digital technology is also playing key role. Things like mobility or virtual augmented reality or machine learning technologies, they're making it easy for oil and gas companies to provide the training on demand through the different media. No longer it's traditional classroom training. The younger generations or the newcomers that can access those courses through augmented reality or the virtual reality technologies. Also, oil and gas companies are investing on the advisory systems. We call them virtual assistant. We have seen those being adopted in the medical industry or the consumer industry in the form of chatbots. So the role of the cognitive advisory, whether it is in drilling or production, would be to capture the expert knowledge and then provide the access to that knowledge to the young engineers or the newcomers who can simply interact with these systems in the natural language and get the right advice from the system. So these are some of the examples of how oil and gas companies are adopting some of the digital technologies to expedite the training and improving their delivery of the training to the workforce. So companies like BP or Equinor or Shell and Saudi Aramco, they are adopting virtual reality or augmented reality technologies to provide their workforce kind of a real experience of the plant and how to operate some of the assets without really stepping into the fields or going to the well site. Okay, and the last is ecosystem focus. So as oil and gas companies, they are getting ready to address all the challenges. They are realizing that they don't have all the capabilities in-house, and they are looking outside for help. And that's where they are tapping into the ecosystem. So a lot of startups are coming up in the industry, coming up with the new technologies. And if you look at the venture activity in the industry, and the venture activity is basically the investments being made by oil and gas industry into these startups, you can see that there is a steady increase in that investment, whether it is in upstream or cleaner energy or digital and other areas. But to do that, it's very important that oil and gas companies they can collaborate easily with the external partners, and that's where digital is also playing a key role. Now today we have got forums like Open Earth Community, which offers cloud platform as a service where different ecosystem players, where we're talking about students or partners or developers or startups or service providers, they can all come together, develop things and share the code base with each other to accelerate the time it takes to innovate or come up with the new technologies. And as an example, if you look at Open Earth Community is a very well-known forum in the industry for collaboration across ecosystems. So today, there are more than 400 companies who are part of Open Earth, and there are more than 3,000 members who are actively accessing it. There are more than 600 projects which have been shared or contributed by these members, and over 25,000 APIs which are also available on Open Earth Community. And any of you, if you want to go to Open Earth Community, it's free of cost. You can log in, you can access the code base which has been provided by companies like us or the operators or the startups or the freelancers, and you can build your own innovation on top of that using cloud platforms. All right, so just to wrap it up, now there are some key success factors that need to be considered to improve the chances of the value of digital technologies. So first of all, digital is not strategy, and many companies or many people, when they articulate the strategy, they say that their strategy is to be digitally transformed, which I think is the wrong way to look at it. Digital is an enabler, so the business strategy of E&P companies would still be around how they can extract oil and gas more efficiently in less time, how they can produce it in a more cost-effective and efficient way. But digital is going to enable them to do that more effectively. The second is thinking big, but starting small, and that's very important because there's a lot of things that you could do with digital. I talked about the use cases, and there are tons and tons of things that you could potentially try to do with these technologies. But you cannot do everything on the day one, and it's always important to start small, target specific problems, solve those problems, show the value, and then go on from there. So there's no standard blueprint which anybody can follow, a guide that somebody can read to start, applying digital technologies. These things require always a bit of experimentation, and not everything goes well. So there's always setbacks, but there would also be successes. So starting small allows a company to learn from the experience, get more confident, and also create the buy-in from the organization by demonstrating the success. The other is no company can do it alone. So regardless of what the vendors are claiming, no company has got all the skills that are required for digital transformation. So oil and gas companies will have to work with different companies, the partners, the vendors. They will have to use different technologies. It's very important to be able to integrate those technologies. So having open architecture is key. Otherwise, the risk is to again ending up with the silos of the technology that don't talk to each other, and that restricts innovations, and that also stifles efficiencies in the operations. And finally, the hard part is it's not people. Sorry, it's not technology. It's always people. So technology is the easy part. It's easily available. Digital technologies are very mature, but people are where many companies struggle, whether it is culture or having the right skill. If people don't buy into the new way of working, or they're not trained to adapt to the new way of working, if they fear digital technologies, then no matter how good technology is, its adoption would always be very limited, and that would minimize the value that oil and gas companies get out of that. Okay, I'll just skip this slide because I'm kind of very close to the allotted time, but let me just conclude. These are some key takeaways that you can look at. If there's nothing else that you remember from this presentation, maybe these are 4 points that you might want to kind of keep in mind. First is the O&G industry is not going anywhere. So despite the talk of all the disruptions and threat from the renewable energy systems, oil and gas is still a very critical pillar to the world energy mix. So oil and gas industry would survive, and not just survive, but thrive. At the same time, oil and gas companies, they are now transitioning to become the energy companies. No longer they would be just purely in the business of extracting and producing oil and gas. They would increasingly become a solution provider to the energy needs. So whether the solution is coming from the hydrocarbon industry, or whether it is coming from renewables or solar energy, oil and gas companies, they would become end-to-end energy solution providers. Then the business model of O&G companies would become more competitive. So the companies who are looking to survive and also succeed, they would systematically root out the inefficiencies and make the supply chain much leaner and more competitive, while being careful about the impact on the environment. And digital is going to be key in enabling that shift. The third is and this is a very important point, because I hear from the younger generation, they're evaluating their career options. Those those the people who are still in the university, they're still wondering whether they want to get into the oil and gas sector, or they should go into the renewable sector, or should they pick up the data sciences. Well, my take on this is, as the oil and gas companies, they would diversify into low carbon business, or they would adopt more digital technologies. I think that would also restore the sector's attractiveness as an employer of choice. So although the sector has lost its sheen in the last few years because of layoffs and also its reputation as a sector that is not friendly to the environment, I think that would change in the years to come. And on that point, new career options would be opened by digital adoption. So many students who are still looking at picking up the employment in the oil and gas industry, I would like to tell them that there are certain skills which would still be relevant as they were in the past, things like domain knowledge or creativity, problem solving, adaptability to the new things, and willingness to learn. But at the same time, there would be new career options. For example, the digital careers around data sciences and cloud, or the data architect, and so on. So there's a lot of exciting things that are going to be available to the young students who are looking at O&G industry as a long-term career option. With that, I would conclude my presentation, and if there are any questions, I'm happy to take those. Thank you for listening.
Thank you, Engineer Hemant, for this very informative session. I'm sure the audience benefited greatly from it. In the meantime, I've collected a few questions for the quick Q&A session. For our first question, someone's asking, if the oil is no longer used as a source of energy and become only a raw material source, just like petrochemical industry, how badly that will affect the oil demand?
Okay, so if you look at the contribution of oil to the different industry, I would say oil would still be required in the transport sector. I don't think anybody today, no matter how pro environment they are, nobody is forecasting that in the next 30-40 years, all the cars and the vehicles and the planes, they would be running on the batteries. That's not going to be happening. So there would still be need for petrol and diesel to run the cars. Maybe there could be hybrid cars, or they could be just purely ICE cars. So there would be some need for oil to fuel the transport sector. Of course, petrochemical is going to be a key consumer of oil, that's for sure. And then there is also the transport sector. So you still need tar to construct the roads and so on. So yes, there would be a decline in the oil consumption, and I think as per the various forecasts, the oil demand would probably peak around 2030, and then it will slowly start declining. But at the same time, oil and gas companies, they need to invest in producing and finding oil, because if you don't do that, you all know that there's a decline of reservoirs every year, and most of the fields they're declining at 6 to 7%. If you don't explore more oil, if you don't do a more field development, that decline, the natural decline, would take the oil production to the level where it is no longer able to meet the demand that is required by the other sectors. So my take on the question is, yes, oil demand would come down, but not to the extent that any investment in oil and gas extraction producing activities will stop. And yes, the key consumer of oil, crude oil, would be mainly petrochemical, followed by transport sector, including the aviation sector.
Okay, thank you. We have another question. How to deal with the bad quality data, and how do we rely 100% on readings? Okay, so there's no silver bullet to the problem of bad quality data. So, you got to look at what is behind the bad quality data. So there are two main reasons. If you're talking about the data that is collected from the sensors,
The quality issues could be because of the sensor itself is faulty. So I see many companies who don't trust the readings that they get from transmitters that measure the flow on the wells, because those transmitters, either they are broken or they haven't been maintained for many years, so they don't trust those. You can't do much about that. You have to make sure that if you have got machinery, if you've got a technology, you maintain it properly. It just it's the same with your car or anything that is running on technology. But then there's a second reason behind data quality: the data that is not coming from the sensors. So we're talking about data that gets collected by service providers, like in logs or the seismic data, or of course you need sensors, but they are not getting streamed, right? So you acquire the data, seismic data, log data, but then you store it on, after acquiring it, you transfer it to some database where somebody looks at the data, they do the quality check, and then they move it to some other data source. Similarly, you've got production data where or drilling data, where somebody is waking up in the morning, they're looking at the operations and they're writing the report. Or somebody is going to the well site, they're looking at the pressure gauge and then noting down the pressure readings, or whether the well is producing or not, those kind of things. Wherever you have those human interventions, whether collecting the data or checking the quality, you're bound to have data quality issues, because humans, we are not good at doing the jobs that are mundane or that are boring, that are repetitive. So what people do is they take the shortcuts, or they make mistakes, or they just don't care about the data, right? So I think fixing those data issues would require a more holistic changes in the oil and gas companies. It's not a purely technology solution. Of course, you can bring in the technology to identify the data gaps, but end of the day, the end users and the businesses, they have to take ownership of the data. They have to care their data as well as they care about their health or their electronic devices or their cars, right? It's as simple as that. There's no other option. And I see in some companies that culture is there, and those companies, data is in good shape. But in some companies, the culture is not there. People are not willing to take ownership of the data. They leave it to IT. So regardless of all the digital technologies they have got, so data sources, the quality of data is very bad. So the solution to data quality is multifold. One is having the right maintenance practices for the transmitter sensors. Second is the right, the leadership commitment and the ownership from the departments. And third is having the right, I would call it information architecture, where you are storing data where it should be stored instead of storing data in multiple spreadsheets. So having the right information architecture and standards for data storage is a third. So these are some of the ways that that could help address the challenge of data quality. But again, this is nothing new. Everybody knows it. It all comes down to the implementation. That's where oil and gas industry has been struggling.
Okay, so we can say that from this vision of digital transformation could be like from the top of management of the company, right? So why we don't see this in the Middle East compared to like in Europe and in US? These countries are believing and supporting the digital transformation vision, but you barely see, like, especially in the Middle East, many CEOs, like, and despite of the fact that they have a lot of advantages, they don't implement it right. So is there any comments about this statement?
Well, I would probably qualify the question. So I wouldn't say that Middle Eastern oil and gas companies, they are not taking digital seriously. And I can already see some of the large NOCs, they are accelerating their digital transformation. But yes, I would say that it's not as fast, or it's not as productive as it has been for some of the international oil companies. And the reason for that could be several, right? Okay, let's look at, the drivers. The NOCs have different drivers from the international oil companies. NOCs, they are driven by different incentives, and NOCs, their objectives are different from the IOCs. So international oil companies are super majors. They are publicly listed companies, and they work according to the diktat of the investors, shareholders. So their business model is aligned to their shareholder goals or objectives, and shareholder wants a return on the investment. So the goal of IOCs and super majors is to maximize the value for their shareholders, which is to improve the stock prices or give the better dividends. And that's why they're under a lot more scrutiny and pressure as compared to the national oil companies. So that's why the super majors or the IOCs, international oil companies, they have adopted digital with more intent and more aggressively than as compared to the national oil companies. National oil companies, they're working for the governments. Although they are in the business of producing oil and gas and making money, but they also have to think about serving their countries. So, producing employment, generating employment, or helping their governments, with some of the social welfare schemes. And they're also looking at the long-term energy supply, because most of these countries in the Middle East, they look at oil as still a very key source of their national economy and driver of national economy. So their focus is to maximize the life cycle of the producing reservoirs so that they can sustain that income on a longer period. So in many cases, the national oil companies, they are not bound by the same objectives or the same diktats as the super majors, and that's why some of the urgency that super majors, IOCs, they are facing in improving efficiency is not there. But with the shift that is happening in the market, and even national oil companies, they realize that they cannot hope to depend on the price recovery. They also have to look at improving their efficiency. That means reducing their cost further so that they can increase their profit on the oil that they sell. And that's why there's a lot of, I would say, recognition of improving the efficiencies of the operations on the value chain. And many NOCs, they are adopting digital to achieve that. The pace is very slow because culturally some of these IOCs, national oil companies, they haven't really been the leading adopter of digital technologies as many IOCs are. And because they have to generate the local employment, not everybody who's entering the workforce is digitally savvy. So some of those factors, they have restricted the adoption of digital, cultural, the environmental, also the skill sets which are there in the different countries. But I'm very positive that in the next few years, you will see the same level of urgency and the progress being made by national oil companies when it comes to digital adoption.
Thank you so much for this great answer. Of course, when someone hear the word digital transformation, always comes to his mind a question, which is, how does the digital transformation will lead to reduce field workers, and does it affect to rise the number of decision makers?
Sorry, I didn't get the second part. Can you repeat that?
Okay. Does the digital transformation will lead to reduce field workers and rise the number of decision makers?
Interesting questions. If you are referring to the managers or the people who are sitting in the office, I guess that's what you mean by decision makers, right?
Yeah, exactly.
Okay. Well, I would say that I used to be a field engineer. I used to work on the rigs, and I can tell you that it's not a very attractive job in the world. It's not even safe right? You're working on the rig floor, you're going out into the field, driving in your car on a daily basis, and then you've got the elements like extreme weather conditions and so on, or extreme cold if you go to the countries like Russia. So it's not very appealing job, right? So many oil and gas companies, they are actually actively working towards reducing the number of people in the field or on the rig floor for two reasons. One is, of course, they don't have as many people to really support, a wider footprint of their operations. So there is an efficiency aspect to it. The second is that they believe that by consolidating or by going to the remote operations, they can actually operate their fields more efficiently. In the other words, imagine if you've got lots of people going to the field to collect the data manually, noting down the readings on the notepad, and compare that with the scenario where companies are collecting data through the sensors installed on the wellheads, and they're monitoring second by second reading. I think the latter scenario is always, I would say, more effective than the first scenario. So there's that aspect also. So I don't know if that will increase the number of managers in the office, but the trend is towards minimizing the number of people in the field or on the rig floor. And also, oil and gas companies are looking to operate with a lean workforce, right? So just because you are, reducing the people in the field doesn't mean that everyone is going to start becoming a decision maker or manager. Those people that can be retrained, and maybe they could sit in the control room or the remote operation center, or they could do something else. So the oil and gas company, they're not just taking those workers from the field and putting them in the roles of the managers, giving them a nice cabin. So I think the better approach, which we will see, is reskilling the workforce, those people, and deploying them in the activities that generate more values and make better use of the skill set. That's where I think things will take place.
Okay, thank you so much. Someone is telling oil and gas will definitely coexist with renewables in the future. Although Europe has established policies such as the Paris Agreement, having stated that, will oil and gas companies be pushed to operate in the Middle East countries and third world countries and change their operations mainly to renewables?
Well, that's an interesting question, right? So,
yeah.
I made a comment early on that international oil companies, super majors, they most of what they do is dictated by their shareholders, and there's a lot of pressure that is coming on them from their shareholders, who are asking them to reduce their carbon footprint and also show their plans to achieve the net emission goal by 2050. So there's a lot of pressure, and I think there was an article in the news that one of the key investors of Shell, they dumped all the Shell stocks because the investor didn't see or wasn't convinced with Shell's plan to achieve the the zero emission goal by a certain period. NOCs, they are not under such pressure. So they work according to, they are more aligned with their governments. So their plans are more long-term. So NOCs or the governments, they will look at the oil demand or the gas demand in the next 30, 40 years. And based on that, they will make those decisions on how much they want to invest in the next 20, 30 years. So when these oil and gas IOCs, they come into the Middle East, they are still working as the partners to national oil companies. So they are there to provide their expertise and help the national oil companies to do things like exploration and field development more effectively and efficiently. So that's the goal. I don't think what IOCs do in the Middle East countries can be influenced a lot by the shareholders. Of course, what IOCs or super majors can do is not invest in Middle East countries because they have very limited leeway in diversifying into renewable energy sources in these countries. But end of the day, I think the super majors, IOCs, they are in a very tight situation. They have to continue expanding their oil and gas production because that's part of their plan and that's their core business model. At the same time, they also need to come up with the right strategy to show to the investors that they're reaching the climate change goals, which is zero emission by a certain period. It's a tightrope walk. I don't know how they're going to achieve that, but sorry, I kind of rambled and I digress. The question, yeah, I don't see that happening. IOCs are, they are driving decisions whether they want, which kind of energy sources they want to invest in these countries. I think that decision would be, my view is that would be purely taken by the national oil companies or the governments based on their outlook of the market and long-term energy needs.
Thank you so much. I think we have a lot of questions, so if that's okay with you to take more.
That's okay.
Okay. Someone's asking, could you elaborate regarding drilling digitalization in terms of preventive maintenance and drilling problems? How the model forecasts while drilling a well, and what is the accuracy of that model?
So, in drilling operations, the way we see machine learning or data sciences technologies being applied is in predicting the failures that take place downhole. Now, these initiatives they have been going on for many years. Things like stuck pipe prediction on early kick detection, where you can absorb the data that is coming from the sensors on the drilling strings and analyze the data and then predict whether there is a possibility of pipe getting stuck or getting a kick from any zone in the reservoir. Now, the success of these initiatives has been not proven at a large scale. So when I say at the large scale, I mean that a company being able to deploy these algorithms across all their wells and the fields. They have seen the success in a limited way, so maybe on a few rigs, on a few wells. And the main reasons for that is the data quality or the adoption by the workforce. The accuracy is a key driver for adoption, of course. And when the data quality suffers, the accuracy also goes down. And when the people they don't see the models giving the accurate results, then they stop trusting the model. So it creates kind of vicious cycle where the bad data creates bad results, and bad results lead to the loss of confidence, and that reduces the usage of models. So these are some of the challenges that are facing some of these machine learning based initiatives in the industry, not just drilling, but also production, right? So that's where we are. But my guess is that as oil and gas companies, they instrument their drilling operations in the rigs and they focus more on the data quality, and the workforce starts adopting the AI and ML based solutions. It will then kickstart a virtual cycle where the more demand for such solution would also lead to the efforts by the end users to improve the data quality. That means improve the sensors and also increase the density of the sensors. And with that, the accuracy is going to improve, and that would also in turn lead to more demand for such models. So that's the way I look at it. But today, it's not really widely used technology in drilling. It's still in its infancy, and my guess is that it will take some time before it fully become mainstream in drilling operations.
Okay. Someone is asking, is migrating ASCLL data, which is, I think, logged from the daily drilling report, to an SQL form is considered by companies, as from what he understands.
Sorry, I lost you there, Hemant.
Okay. So someone is asking, is migrating ASCI...
Can you hear me?
Yeah, I hear you well. Can you hear me? Hello?
Hey, I lost
Can you hear me?
Yeah, I can hear you now.
Okay. Yeah. Okay, sorry for that. Someone's asking, is migrating ASCII data, which is logged from the daily drilling report, to an SQL form is considered by companies? Like, as from he understand, it will be easier to build machine learning models from Python and SQL programming. I hope this is clear.
No, I didn't get the question. Come again one more time.
Okay. Is migrating ASCLL data, okay, which is logged from the daily drilling report. So he's asking, is migrating this data to an SQL form is considered by companies? As from he understand, it will be easier to build machine learning models from Python and SQL programming.
Yeah. Well, I think the question is about ASCII data to SQL, right?
Yes, exactly. Yeah.
Yeah, ASCII data, I would call it still a structured format. So you can still convert your ASCII data into SQL format, and there are many ways to do it. I don't think that's technically a demanding task, because data is structured. You can still have your data in ASCII format that brings some structure to it, and then you can write the business rules to make that conversion. Coming to the reading a natural language text using machine learning is a different ball game. If you look at something like this, what you see on the screen, it's a document. If you were to read data from this, that is something which cannot be simply done by writing rules, because natural language is something which is vague or not really amenable to any standard interpretation. There's always some kind of context that goes with the natural language. One person can say something and that could be understood by different people in different ways. So that's why machine learning is becoming quite popular when reading the natural language text. At the same time, given the complexity of interpreting the natural language, you need to have lots and lots of data to train the algorithm. So whether you write that in Python or any other technology, that doesn't matter. I think key here is the data. So how much data you can feed to the model to learn the ways of the language for a specific domain. So in this case, the oil and gas company had thousands and thousands of documents. So that's a very rich amount of data set, and you can have better chances of an algorithm being able to train itself with that amount of data. But if you just don't have enough data, if you are training the model on 20 documents or 30 documents, whether you write that in Python or any other language, it's not going to be material. You're not going to see a model that is good at understanding the text from the unstructured records. I don't know if I answered the question.
Yeah.
That's my take on that.
Okay, thank you so much. We have final two questions. Since we are having like a lot of audience from like students and fresh graduates, and they are very interested to take part in digital transformation in the oil and gas industry. So we have two parts here. So the first part is asking which career or which division in the future will take more parts in the digital transformation applications. Like, should someone go through petroleum engineering or go to CCUS or maybe to renewables or maybe to LNG operations. So what are your recommendations toward this?
All right. I think it's, again, important to revisit this slide. So the gas is going to be a key source of the energy in the future. And gas comes from underground, right? So that means oil and gas companies would be involved in finding and producing gas. And whether you produce oil or gas, you still need to apply the same technologies and business processes and the skills to do that. And at the same time, there would also be continuation of the oil exploration and extraction by the companies. So if you think about the career option, you know, I talked about this, right? How the E&P companies are transforming themselves. So they are transforming themselves around the data, the process, skill, and ecosystem. And there are opportunities across the value chain. So if you are, let's say, in subsurface, or if you are a drilling engineer or you're a production engineer, all of these three disciplines would still be pretty much required, because you cannot produce, you can find oil or gas without having geoscientists in the team, or you cannot drill a well without having somebody to design the wells or somebody to drill those wells. So there would be need for all these disciplines in the future. Now, the challenge would be to have the right kind of mindset and the skill sets, or the I would say the attributes that would make one more successful geoscientist than the other. So I wouldn't rule out the importance of domain knowledge. Domain knowledge is going to be key. You cannot be a good geoscientist if you don't know your basics, you don't know your the fundamentals of the domain. So that's absolutely must. Then on top of that, you got to be able to have a problem-solving mindset. So, I see the future workforce. I'm kind of trying to, I'm thinking aloud to phrase my answer properly. So, the future workspace is going to be a lot more collaborative, and as the companies that bring in more digital technologies, there will be a lot more integration between the different disciplines. So, being able to work in the teams, it becomes very important. Being able to solve the problems, different problems, is very key. And being able to learn new things is also important. So when there's new technology in the future and that changes the work process, how quickly you can adapt to that. These are very much important attributes, right? If you have those attributes, you'll have a great career, whether you're a geoscientist or a drilling engineers or reservoir engineers. I'm not in a position to say that yes, one should take up reservoir engineering as a career option because it pays better or it has a better viability or outlook in the future. I'm just not in a position to say that. All I can say is that the traditional careers in oil and gas sectors like geoscientist or drilling or reservoir would still be in demand. However, the expectations from the newer workforce would be very different. The companies would expect them to be a lot more multi-skilled, more collaborative, and more creative in the problem solving, not just be purely working in the silos where a petroleum engineer says, I don't want anything to do with the geoscientist. I don't want to understand what they do. Or a geoscientist says, I don't care about what the reservoir engineers do because they don't impact my job. All right. So those kind of behaviors would no longer be accepted in the future, and they would not even, help the E&P companies or oil and gas companies in the long run. So that's my advice to you, anybody who's considering the career options. If you're passionate about oil and gas industry, there's a future in it. Just go with the passion. Go with if you like geology, be a geoscientist. If you like reservoir engineering, be a reservoir engineer. Don't just go with the attraction of more money and do something that you don't find interesting or you don't have aptitude for. If you have passion in the geoscientist and you can be a great geologist, I'm sure it will open up a lot of career options for you, and you'll have a very rewarding career down the line.
So this clarify many points. Like it's the domain knowledge is very important than the skills needed, right? So beside the skills that you have said, Engineer Hemant, creativity, problem solving, and adaptability and teamwork, for someone who is willing to start his journey into technical and learn more about digital transformation, what are the minimum knowledge should he get? Like, for example, what program language should he take? Which basic knowledge? Is there enough answer for that, or enough set of skills related to the digital transformation?
Yeah. Well, when I was a student myself, I used to learn Fortran because I was told that that's a key programming language that everybody should know. And when I joined my first company and I got a bit fascinated with the programming, I started learning C or C++ because that was the popular programming language. Today, everybody is running after Python because Python is the latest flavor, right? I'm not sure 6 years down the line, people would still be coding Python because technology world changes very, very fast compared to, let's say, oil and gas industry. So if somebody who is a petroleum engineer and they want to get into digital transformation, and they're asking me, should I be learning Python? My answer is always, if you are passionate about learning something, then just by all means do it. It's the same way we are passionate about sports, so we build our skills in basketball or football, or if you're passionate about reading, or passionate about things like drawing or painting, we learn those things and we become better at those, right? But I would caution somebody who is learning Python because they think that without that they cannot succeed in their career or they cannot take part in digital transformation. To me, that is a wrong way to look at it, because technology would change. You may spend a lot of time learning Python, but 5 years down the line, it may not be of any use, because then there will be some other language. Today people are saying down the line, technology will be so advanced that you can just do coding by talking to a computer. In natural language, you can write the codes. That's what people are talking about. So instead of spending time in learning technology for the sake of it, I would rather advise people to spend more time understanding more about the industry, the trends which are happening, are developing, what the different companies are doing. Read more articles, read more SP papers, look at what's going on, and go into your career with the mindset of learning as you spend time there. So don't worry about Python or being part of digital transformation or not. It will come to you once you show your capabilities in the new company organization. You show yourself as a great team player. You prove your ability to solve the problems. The people, they would seek you out and they would make you part of the projects or digital initiatives that are going on. And I work with many companies, almost all the Middle East companies or North African companies I'm working with. And I see that in many projects, there are many youngsters who are part of the team. And many of those, they are always writing SE papers. They are talking about technologies. They are doing something. They are trying to make a difference. Whether they know Python, maybe not. Maybe they learn different things. But as long as you can show your value, prove your value in your new company, the digital transformation, those opportunities will come to you automatically. But focus more on the domain knowledge, the industry knowledge. Focus more on learning new things. and deepen your specialization, right? Don't be shallow. Don't be somebody who knows a bit of geosciences, bit of petroleum engineering, bit of well planning, but who is a fantastic Python coder. That's not going to cut it. Then you'll be, one of the 100 people in the, or thousands of those people in the industry who come with the same skill set. So pick your niche, geosciences, or data sciences, whatever it is that excites you, deepen your expertise in that, find your first job, prove your value, try to make a difference, and then leave the rest to time. The opportunities will find you, and if you can make good use of those opportunities, you'll go from strength to strength. That's advice I would give.
That is very inspiring advice, Engineer Hemant. Okay, so now thank you all for answering all our questions, Engineer Hemant. This, guys, concludes our quick Q&A session. Again, thank you so much, Engineer Hemant, for the great lecture. I believe the participants have learned everything very well. At the end, Engineer Hemant, we highly appreciate your time and efforts that you have given us for educating us about digital transformation in the oil and gas industry. And we expect to have some more from you in the future. Dear attendees, thank you so much for joining us from all over the world. I hope you enjoyed our course, our session today. Until then, please take care, stay safe, and all have a good evening. Thank you.
Thank you so much for everyone's time. And I know it was a 1-hour session, but it went way over time. So I appreciate you taking time out. And I also enjoyed your questions. I think they were really great questions. They really made me think hard. So it's possible that I may not have been very succinct and clear in my answers because I had to really think about what would be the right answer. So those are my opinion based on my experience. But if you still have any follow-up questions, or if you feel that I wasn't very clear in answering any of your questions, you've got my email. Feel free to reach me or call me. Hemant has my number. So I'll be happy to spend time having further discussions with any of you.
Thank you so much, Engineer Hemant. It's our pleasure to have you again. Thank you.
Thank you all. Thank you very much.